Alright, so in this video, I'd like to derive the graph of tangent first, and then based on that, we'll figure out the graph of cotangent using some of that 1 over tangent type of reasoning that we used with 1 over sine and 1 over cosine. So, the way that we'll come up with the tangent graph is by starting with the unit circle and interpreting what tangent is on the unit circle. And so remember, we're going to define our angles coming out of standard position. So this will be my theta that rotates around, and I'll get different radii that's going around the circle there. And remember that tan theta in this diagram is basically the same thing as the slope of that radius that I drew there. Okay. So if we make a graph where this is my theta axis and y equals tan theta, then we can figure out what this thing looks like. So when theta is 0, then you're flat across here. So that has a slope of 0. So when theta is 0, tan theta is 0. And as theta works its way up here, it gets steeper and steeper and steeper, so the slope keeps going up until just before 90, our slope is practically infinite. So this is, well, actually, let's work in radians. So I'll make this pi over 2 up here. So just before pi over 2, or sorry, this is theta, not x. So just before pi over 2, this shoots way up to infinity because the slope gets super infinite there. And then just after pi over 2, it's super negative. It's a very steep but negative slope. And then it comes down like this, and eventually it flattens out right at 0 again when we're at 180 degrees or at pi radians. So this thing starts out, again, we said it was a really negative slope just after pi over 2. So really negative slope. And then it works its way back to 0. And it hits 0 right here at pi radians. So at pi radians is when we get to 0. Then, if you think about what happens right after it, well, that's the same as what happened right after we started moving in the first place. So when it was just a small number of degrees, that's the same as when it's 180 or pi plus that many. So we start repeating the slopes. So just like it went up here, it's going to go up here. And then I'm going to get another one here. It's going to go vertical again at 3 pi over 2, so it'll be no slope there. And then we're just going to repeat the process one more time. So over on this side, it's going to do the same thing but go down. And then this will be theta equals negative pi over 2. One other set of points that you can figure out pretty easily would be when the slope is 1 and negative 1. So when is tangent 1 and when is it negative 1? So let me redraw this unit circle. Slope is 1 right between 0 and 90 degrees, or 0 and pi over 2 radians. So this happens at pi over 4. So at pi over 4, you get a slope of 1. And that's going to repeat pi units later. So you're going to get another one here at 5 pi over 4, if you wanted to figure that one out. The other thing is, at negative pi over 4, you're going to get the slope of negative 1 right here. So we've got 3 points that are useful to know, and then all the rest of them you can get just by shifting pi units over. So the 3 important points are 0, 0, which is pretty simple. This one here is negative pi over 4, comma, negative 1. And this one up here is pi over 4, comma, 1. So these 3 points are going to be the 3 points that you end up shifting and stretching around whenever you need to graph something like tan of, pi over 2, parentheses, x minus 3, stuff like that. Okay, so here's the graph of tangent one more time. And now we want to analyze this to get the graph of cotangent. So to get the graph of cotangent, well, that's the same thing as 1 over tan. And so anywhere that tan is 0, cotangent's going to explode with those vertical asymptotes. So anywhere that tan is 0, cotangent is going to have this asymptote at it. So it's 0 here, asymptote for cotangent. Tangent 0 here, so asymptote for cotangent. 0 here, asymptote. 0 here turns into an asymptote. And then if you think about, okay, so tangent, like at negative pi over 2 is undefined, but just before it, it's positive infinity. Just after it, it's really negative infinity, or it gets close to those values. And cotangent is 1 over tangent. So whenever tangent is positive or negative infinity, cotangent is 1 over positive or negative infinity. 1 over plus or minus infinity is 0. So anywhere that tangent explodes to positive or negative infinity, cotangent 0. So that means that cotangent is going to be 0. I'll do this in red. Cotangent is going to be 0 here, and here, and here. Anywhere where tangent had an asymptote, now it's got a 0 for cotangent. So that's kind of easy to remember because you're just switching the asymptotes and the zeros between tangent and cotangent. Now we got to figure out like what happens when I approach one of these red asymptotes. So when tangent gets really close, let's look at this one here, right? So when tangent gets really close to pi over 2, but on the right side of it, it goes up to infinity. And so if I plug in that same x value, then I'm going to get positive infinity on the bottom here. So 1 over positive infinity is 0, but positive. So this is going to be real close to 0. And we know that it goes through 0, but it's going to be positive. So, and then over here, tangent is really close to 0, but positive. So 1 over that is going to be really close to infinity, and it's going to be a positive infinity. So let me get this stuff out of the way, and I'll repeat that one more time. So since it's going up to infinity here, and negative infinity down there, at pi over 2, you could kind of think like, oh, it's both infinity and negative infinity, and 1 over that is 0. So it's got to go through 0 right here. And when we look over here, tangent is a small positive number, and cotangent is going to be 1 over a small positive number, so cotangent is going to be a really huge number up here. So we can figure out that the graph kind of does this thing. Then at pi, tangent is a really small, negative number. So cotangent is going to be 1 over a really small negative number, and 1 over a really small negative number is a negative infinity kind of number. So now we've got this. And then it's going to repeat every pi radians. Just like tangent's got a period of pi, so does cotangent. So if I move this over, you'll be able to see what it looks like a little bit better. So there it is. Here's the x-axis. And the y-axis is actually right through this asymptote. Whoops, that's the y-axis. X equals 0. This would be x equals pi. X equals 2 pi. This right here would be pi over 2 comma 0. Right there. And if you wanted to, you could figure out a couple other points, like this one right here would be pi over 4 comma 1. And down here, we get a 3 pi over 4 comma negative 1. So those are some useful points that come in handy once in a while. So, okay, hope that helps.